Your syllabus is all
yeah, you can use it, but you are limited to access to lecture slides. The reason I allow you to use laptop is that you don't
like a C-mentioned book is fine as well, right?
Except for Sunday. No. I haven't watched any. I haven't watched it. Oh, cool. Yeah, I've seen it.
Okay, so let's continue from where we stopped on Wednesday. So we talked about some basic features in SQL. So we're going to continue the discussion, and hopefully we will be able to wrap up the discussion on SQL by the end of today's lecture, or at least by Wednesday's lecture. Right? Okay, we talked about self-join and the usage of alias, the range variables, and the renaming operator as in SQL. Right? A quick recap of what we said here is that you can use the renaming operator to rename the output of an attribute, as well as to rename a whole SQL block, which gives you a relational instance as its output. Okay? And the renamed instance can be then used as the input to another relation. Right? For example, what I mean is you can certainly do things like this from this relation, and rename this whole thing as T. Okay? Then you see from sailors again, where T dot H2 equal to, right? You can do things like this. What this query does is to pair those sailors together into one T, such that one sailor's age is 2 times of the other sailor's age. Does that make sense to you? So we actually went over this example towards the end of last lecture. Okay? In the construction of this query, we are using this entire block from here. You can see my mouse. So basically from the opening bracket to the end of that bracket, to the closed bracket, that entails one complete SQL block. And using the renaming operator as, you can rename that entire SQL block into a relational instance called T. Okay? Then subsequently, this alias T represents that particular relational instance, which is the output of that SQL block. And you can use this to construct the remaining part of your SQL query, which is to say T.H2, and note that H2 is renamed in the construction of that instant T, which denotes 2 times of a sailor age. Then your condition is to say H2 equal to, you use another alias S1 to refer back to the sailor's instance once more. And your condition is to say H2 equal to sailor's.age. So effectively what you're doing is one sailor's age is 2 times of the other sailor's age. If that's the case, I'm going to output these 2 sailors together in a pair. Does that make sense? Okay? So go ahead.
Would it be, so it's limited
Can you speak louder so people in the back can hear you?
But is it limited to the name Dustin, or is it not in this case?
So the T is limited, of course, to the sailor's name Dustin.
Oh.
But there's no such limitation on S1, on the second sailor.
Oh, yeah.
Okay. All right. Now, let's talk about string matching in SQL. So you can do exact matching in SQL, such as you say sailor name equal to Jim. You can do things like that. Okay. This will return all sailor name equal to Dustin, right? This will return all sailors' names with this particular string value, Jim or Dustin, right? In our examples. What if you're not sure the spelling of a particular person's name, or you know the spelling of the person's name, but there are possible multiple values you're looking for, right? Suppose you're looking for a person called Jim, there's another person called, let's say, for the argument's sake, there's another person called Jan. You want to find both such persons in one SQL query, right? One way to do this is to say this, or right? Use an OR operator to connect two conditions. But what if I give you multiple choices down, to expand this list even further, right? With some character in between J and N. How do you do that? The convention in SQL is to use what's so-called approximate matching. So what that means is you use some wildcard character. In particular, there are two such wildcard characters to construct approximate matching. One is the underscore character. The other is percentage character. What underscore means is to match any one character. Match any one character, okay? What percentage means is match zero to more arbitrary characters. 0 to more. Okay? So that's the difference between the two. And you can use a combination of the two as well. With that being said, let's look at what this particular query does. What this one says, I'm matching, of course, by the way, when you use any one of the two in constructing your string matching conditions, you have to use the keyword like instead of using the equal sign, because you are no longer doing exact matching. You're doing approximate matching. So the keyword like will trigger approximate matching instead of exact matching. So in this particular example, let's look at. I'm gonna copy that example to the whiteboard. So using this definition of the wildcard, what this query does is I have an underscore, meaning that you need to have at least one character between the letter J and the letter N. At least one character. And maybe 0 or more after that. That means that this is a match, this is a match, because this I and A will match that underscore character. And then there's nothing after I and A in before M that match with percentage. That's okay, because percentage means 0 or more. Follow me on this? Let me give you another example. If I change this name to, let's say there's somebody named as this, the spelling of the name is like this. This will still match with this condition because this A is the underscore, this E is our percentage sign. You follow me? I can even have double E here, which still matches the percentage sign. That's good? Question?
So if the percentage sign would be after a normal character, like a letter, so would you need just multiple number of that letters? Like let's say.
No, it doesn't have to be multiple of the same letter. It can be, I don't know, anything.
Is it
0 or more combination of different characters.
So it doesn't matter.
All same characters.
So it doesn't matter if it had an underscore before it. It's any character.
No, I don't get the question. If you're saying
if you had J, I, and then the percentage sign, yeah.
J percentage, you mean what's your query condition, by the way?
What?
Is your query still this? I'm
No.
talking about it with respect to this particular query.
I'm saying if you made a new query instead with J percentage sign.
J, okay, construct a new query, J percentage M. Okay.
Yeah.
And would that be a match to this? Are you saying that? Yes, because then this whole thing AEE will be
Okay.
my percentage.
So it accepts any character. Okay.
Except, yes,
Okay.
I said 0 to more arbitrary
Oh, okay. Sorry.
characters. Not the same character, arbitrary. Question over there?
You might have already said this, but the underscore is exactly 1, right?
Exactly one. So that being said, if I change back to this condition, this will not be a match. With only J and M, this will not be a match to this because you need to have at least one character between J and M. If I remove that though, this will be a match to this because percentage means 0 or more. Now I'm okay. That's the difference of the two. Does that make sense? Question over there? Yes.
What if you need, for some reason, you need the actual character percent in your,
You mean I need exactly 2 or 3 characters in between J and M. Then you use multiple of underscores.
no, I mean just like, is there a way to escape, like say I'm looking for the actual string, J percentage M?
Oh, I see. So you escape that.
Yeah, is there a way to
Yeah. There's a way. There are different ways. They're gonna for different data. So let me repeat the question so the rest of you follow me, right? What he was saying is, I really want to match. I really want to search, do an exact search on somebody named as J percentage M. I mean, you don't find this as their person name, but maybe somebody uses this as their Twitter ID or whatever. That's possible, right? So I want to do an exact match like this. Then you simply use equal sign.
Okay, but you couldn't have a percent character in your like statement?
Depending on, if you like, you use percentage, then most commercial database engine will interpret this as a wildcard match. Some commercial engine will allow you to escape this, but it really depends on the particular engine you are using. So you have to look at their product manual, see whether they allow you to escape this when you are doing a proximate matching. Does that make sense? Okay, cool. All right, so that's, of course, you can use this, by the way, you can use this wildcard anywhere in your query construction. Let's say you want to do something like this. That means, oops. What that means is they allow, so now I allow you to have 0 or more character after this. For example, then I can match something like to this. Why? Because this A is my underscore. There's nothing between A and M. Match that percentage, that's fine. But this ES match my percentage. Afterwards. Okay? So far so good? Now let's look at how we do compound logic. Compound logic means you have more than one query condition, right? We saw example like this in the end of the relational algebra discussion, right? Find the seeders who have reserved a red or a green bolt. Reserve a red or green bolt. So the way you do this is to do a join between bolt and reserve. The reason for that is the color of the bolt is only available in the schema of the bolt table, which is not available in the reserve table. Henceforth, you need to join both with reserve in order to limit you search to only those bolts with red or green color. Furthermore, when you join bolts with reserve, you make sure the join condition is on the bolt ID, because you want to make sure you're looking at a particular reservation record with respect to that same bolt. Okay? You're not looking at the reservation record with a different bolt. Right? The only way to ensure that is to use bolt ID equal to bolt ID as your join condition. Does that make sense? So far so good? Henceforth, I construct a join between bolt and reserve with the condition that bolt ID equal to bolt ID. And color can be either red or green. Then for those matching records from my join results, I produce the seal ID. I produce out the seal ID. This gives me the sealers who have reserved either a red or green color bolt. Okay? Of course, this is not only way to do this query. Another way to do this query is to use the union keyword. Right? Just like in relational algebra, we have a union operator. Most SQL engines have a union operator as well. So you can construct two SQL blocks and simply union them together as you final output. Okay? Of course, similar to the requirement of the union operator in relational algebra, this block and this block, these two SQL blocks, in order to union them, they must be union compatible. What that means is the schema of this block, the output schema of this block must be the same to the schema of the second block in order to apply the union operator over them. Does that make sense? For example, you can union SID with SID, but you cannot union SID with, for example, put out bolt ID here. That doesn't make sense. It's an invalid construction. Okay. What if you want to find sealers who reserve a red and green bolt? It's tempting to take this construction on top, right? Using a join, then the logic operator all, and it's tempting to say, okay, I simply change that condition all to and. But obviously, this is the invalid construction, because if you do this, you end up with no bolt. There's no single bolt colored at red and green at the same time. So this will end up returning an empty instance back to you. There are no such bolts. What you have to do is to use a self-join or an intersection operator. Let's look at the self-join example first. So the right way to construct this query in SQL is as follows. First of all, you use one combination of bolts and reserve, which is B1 and R1, where the condition is bolt ID equal to bolt ID, R1 bolt ID equal to B1 bolt ID. Let's ignore anything that has R2 and B2 in it. Let's ignore all those conditions with R2 and B2 in it. Does that make sense? Imagine you're reading this query, but only look at this condition involving R1 and B1. And condition A, B1 color equal to red. What do you get? You get, what do you get? You get those sealers who reserve a red color bolt. Does that make sense? Now imagine you do the same for R2 and B2, what do you get? You get those sealers who reserve green color bolt. Does that make sense? So on one hand, you got sealers reserve red color bolt. On the other hand, you got sealers reserve green color bolt. Finally, what do? You join them together by saying, okay, from R1, R2, sealer ID must be the same. Those must be the sealers who have reserved a red and green color bolt. That's the construction of this query. Any questions on this? Go ahead.
So you're saying that the R1, B1 is like associated with the red color only in this?
Yes, because I enforce the condition B1 color equals red, B2 color equals red.
Oh,
Okay? Yes?
Will it matter if you select R2 SID
Doesn't matter because I have the condition r1.sid equal to r2.sid. So at the end of the day, at the end of this query, whether you put that out r1.sid or r2.sid, those two columns have identical values anyway. So it doesn't really matter which one you put out. Okay? A more intuitive way of writing the same query is to use the renaming operator. Okay? This query is fun. But if you look at it, it's somewhat tricky to understand at first sight. If you look at it, it takes some time to understand what's going on. So a more intuitive way of writing this query is to use the renaming operator we have just discussed. What you do is the following. Ignore the outer block. Look at this inner block, which is the block involving only R1 and B2. What does it do? If you look at only this block, what does it do? Can someone tell me what does this block do? I call that inner block, right? Because it's enclosed by another SQL block. So it's the inner block. What does the inner block do?
It's just getting all the sailors who have reserved a green code.
Yes. To be more specific, you get a list of sailor IDs who have reserved a green color boat. Excellent. And I rename that as GR, as green. So now this GR is a relational instance with a list of sailor IDs who have reserved a green color boat. Does that make sense? That's good. Now using this GR instance, this green instance, which is simply a list of sailor IDs, I supply this as the third relation to the outer block. The outer block has two relations, which is B1 and R1. Then the third relation is GR. Then my condition is B1, R1 of boat ID equal to B1 boat ID, B1 of color equal to grass. So far, this part is to find sailor IDs who have reserved what? A red color boat. Then I limit those to join with the sailor ID in the gray. Does that make sense? Okay. So if you compare this construction with the earlier construction, the two logically they are identical. It's like saying Eagle won the Super Bowl. Patrick lost the Super Bowl. It's the same thing. Right? But if you're Eagle fans, you prefer this query much more, right? Eagle won the Super Bowl. You prefer the positive approach, meaning that it's more intuitive. That make sense? Yet another approach, even more intuitive approach, is to take this approach and make it even more explicit. Using the renaming operator one more time. Okay, one block, which will give me the green IDs, the other one give me the red IDs. And I simply join them. That's it. Do all of you follow this instruction here?
So when we talk about from,
Yes.
semantically, I think means like a cross product, right?
Yes.
So is this cross producting
The cross product between RR
and
and GR is a cross product between two lists of sailor IDs with the condition sailor ID equals sailor ID. So it's a join between the two. Essentially, you're doing a join. Okay? Where your RR is, you rename RR as those boats join with reserve with a condition right? And you green the same thing, change this condition to gray. Okay? That's what if you write this in relation algebra.
See, if you use the RR before it's defined.
As I said last time, what's the scope of range variable? Let me ask you this.
query?
Right? I ask you a question.
Me? I
Yeah.
said I don't know.
Yeah, so we talked about last lecture. The scope of range variable is the entire SQL block. It's not as a programming language variable where the scope of it is only after it's first declared. So that's the difference, right? We talked about that last lecture, right? The scope of range variable is the entire SQL block where it's declared. That being said, you can actually use before it's the line, the declaration of that range variable, as long as it's in the same block of SQL array. Okay? Now, instead of doing a join between the two, another approach is to do an intersection of the two, right? Instead of joining them together, you can also intersect them together. Right? CID intersect with CID. Okay? But keep in mind, intersect, as we discussed, is not one of the basic operators in relational algebra, right? What that means is some commercial database engines do not have this keyword defined. I believe it's not even defined. Is it defined in MySQL? Let's do a test. Okay. Okay, this gives me all the CID, student ID from this. Let me do.
See it.
Huh?
Can't see it.
That's good.
Oh, okay, you didn't say it. Okay. So all I'm doing is to find student ID from student table. Okay. Now what I want to do is to test whether intersect is available or not. Simply do. This should just give me the same set back. Intersecting with the set itself. Okay, intersect is not defined in SQL. That makes sense? So you may be able to find out, but with that, in relational algebra, you can express intersect with the combination of other operators, right? Let me ask you guys, one of you to tell me how to do that. How do you express intersect with the combination of basic operators? Go ahead.
If it's A intersect.
Yeah, let's say A intersect B. What are they equal to?
It's B minus parentheses B minus A.
B minus bracket and?
Yeah, B minus A.
Okay, very good. And is there another way to construct this square? It's symmetric, right? You can also do this. Okay. Speaking of which, how do you do set difference in SQL? The keyword for set difference in SQL is except. Example, find the CIDs who have reserved a red, but did not reserve a green boat. Well, the way you do this is to find the CID who reserve red color boat, find the CID who reserve green color boat, then you use except between the two. That's effectively as doing a set difference between the two. Okay, what's over there?
Is it okay if we use the intersect in our homework?
It's fine. Yeah, in your homework is fine. Yes. Unless I explicitly ask you to express intersect. Next, I'm going to talk about nested queries. We actually have seen this to some extent, right? So, this is already a nested query, right? In the sense that, what's the formal definition of nested query? Nested query, typically, an SQL query has one single SQL block. A single SQL block consists of the basic elements of an SQL query, which is select clause, from clause, where clause. That's called one SQL block. Does that make sense? If you have more than one of such, then it's considered as a nesting. So in this case, I have one select from where, but in the construction of that, I'm using another select from where. So that's the second block. what you're doing is you're nesting a SQL block, which is this select from where to define the green CLIDs. Green CLID means those CLIDs who have reserved green color both. What's happening here is you're using a SQL block, select from where, to define a relational instance to facilitate the construction of that outer block. So we call this the inner block. And the one on the outside called outer block. Okay? So that's the terminology we're going to use. And when this happens, we call this is a nested SQL operator. A nested SQL. Because you're nesting multiple levels of select from where in the construction of a really complex SQL query in the outermost block. Outermost block means that you may have multiple levels of nesting. And I'm referring to the one as the top level. Yes.
Cell has the entire scope, right? Even if it's the inner or the outer. The outer would have.
What do you mean by scope?
So
scope of what? Scope of the range variable?
Yeah, so if you have
scope of range variable is the block where it is defined. It's the block it is where it is defined.
So would B2 and R2, could you, I think I said, I'm not sure.
No, B2, R2 you cannot use in the outer block because,
oh, okay.
Look at what I said. Right? What I said is the scope of the range variable is the block where it is declared. So tell me where B2, R2 is declared in the inner block. So the scope of B2, R2 is only the inner block. Does that make sense? Mm-hmm. Okay. All right. However, that being said, can you use B1, R1 here? No. Let me throw the question the other way, right? Can I use B1, R1 in the definition of in the inner block? Yes or no? You said yes. Can you explain me why?
It's part
yes, no, the one behind you. Yes.
Because the inner block is part of the outer block. So
yes, because inner block is part of the outer block. Period. Right? But inner block is part of the construction of the outer block, but outer block is not part of your inner block. Henceforth, the answer is like that. Okay? All right, so let's continue the discussion. Now let's say we want to find the name of sailor who reserved both 1 and 3. This actually is a fairly straightforward query. You don't have to use a nested block to do this. The most intuitive way of doing this query is simply doing a join, which I'm going to write down on the whiteboard. I think we saw this query already in the earlier discussion. You simply do a join between sailors and reserve. Because your goal is to find the name of a sailor. Otherwise, if your goal is to just find the sailor ID, you don't even have to do a join. You do a selection over reserve, you're done. But because you're looking for the name of sailors, you do have to join sailor with reserve. You say select sailor name from sailors reserve with the condition that sailor ID must match against each other. And of course, we're talking about both ID equal to 1 or 3. You're done, right? A simple join between the two, you will be able to find the name of the sailor who reserved both 1 and 3. Now, but let's say you want to do this using a nested query rather than a join between 2 tables. This is a join between 2 tables. Which simply translates to the relational algebra of reserves, where then you put that out. So that's essentially what we're doing in this SQL query. Right? All of you follow this? Now suppose I want to do this using a nested query construction. What would you do is, very intuitively, in the inner block, I'm going to find those set IDs who reserve both 1 and 3. So the inner block does nothing else but just give me a list of set IDs reserve both 1 and 3. Okay? And in the outer block, what I will do is I go through the setters table, and I'm going to use this keyword called in. I'm going to introduce this keyword, which is, by the way, I'm going to erase this, okay? So this keyword in, what does it do? The semantics for this keyword is as follows. You supply a value. You say value in a spartan set. Okay? Okay, we talk about the difference between market set and set. Can someone tell me what's a market set? And what's a set? What's the difference of the two? I'm going to call somebody with that back. Can you tell me what's the difference of market set and set? Yes?
Repeat the question. What was it?
What's the difference between market set and set? You know? Huh? Not sure. Not sure is not good. Okay? You should know this. We talk about this like more than once. Okay, person next to, yeah.
Multi-sets are allowed to have duplicates, whereas
Yeah.
sets are unique.
Very good. Market set allows duplicates, a set does not allow duplicates. Okay? It's not cool to say not sure for answer like this, by the way. It's not cool at all. It's like watching Super Bowl and ask you what fumble is. You tell me, I don't know what fumble is, but you still enjoy the game. Impossible. Okay? If you don't know the difference between market set and set, think you're gonna enjoy the midterm? No way. Okay? But it's fine. Don't feel pressure. You still have time to make up. That's why I call you to answer this, right? Okay. Speaking of which, last night I was watching Super Bowl, and toward the end of the game, I said, this is a boring game. There's not even a single fumble. Then that happened. And you won. Okay? All right. So you can use this over a market set, which is an important distinction, which I will talk about this later on. So this is, by the way, this is a Boolean expression. This is a Boolean expression, meaning that this evaluates to either true or false, depending on the specific value you're using and the specific market set instance you supply here. When does it evaluate to true? When does it evaluate to false? It evaluates to true. Okay? If and only if. If and only if means both sufficient and necessary condition. Right? Do all of you know the difference between if and only if versus if? So I play tennis tomorrow if and only if it's sunny. What does it mean? Can someone explain that to me? Go ahead.
If it's cloudy, you're not going to play tennis.
And? And if it's sunny, I'm gonna play tennis. There's a difference, right? What you said is only if. Right? I only play tennis tomorrow if it's sunny. But it doesn't mean I will play tennis if it's sunny. I will play tennis tomorrow if it's sunny. That means if it's sunny, I will play tennis. But it doesn't mean I will not play tennis if it's not sunny. Meaning, if somebody tells you, I will sell this house to you if you pay me 200K. Right? Don't be tricked by that statement. That doesn't mean he agreed to a contract of 200K. Right? Okay. So it's if and only if condition here. Evaluate to true if and only if this value belongs to this market set. Evaluate to true, evaluate to false otherwise, meaning the value is not in the market set. Okay? Question on this? Now that being said, let's look at what's going on here. In the inner block, I find all the CID who reserve both 1 and 3. So it's a list of CIDs. Now let me throw the first question to you guys. That list from the inner block, the list of CIDs, is that a set or is that a multi-set?
Multi-set?
Can you tell me why?
Because it's just talking about who reserves 1 or 3
Yep.
on different days.
The same sailor, in other words, very good by the way, the same sailor may reserve both 1 and 3 multiple times on different dates. So it's potentially it is a multi-set. It could still be a set if each sailor, for those sailors who reserve 1 and 3, they reserve 1 and 3 only once. But that's a very strong condition. In the instance we're using, that may not be true, right? So you may well end up with a multi-set. If the same sailor reserve both 1 and 3 multiple times on different dates. Can the same sailor reserve both 1 and 3 on the same date multiple times? Can the same sailor reserve both 1 and 3 multiple times on the same date? Using our input instances. Yes or no?
The key is date.
The key is, very good. This question indicates you know the answer, right? The key of the reserve table is what? It's a combination of CID, OID, and date. The fact that the combination of them is the key indicates that the same sailor cannot reserve the same boat more than once on the same date. So that will lead to duplicate records in the relational instance, which is violation to the very principle of relational model. So far so good? So I may have duplicates, so this is indeed a multi-set. Okay? Now, the outer block, the critical observation is you simply view the outer block as a for loop. So you read this as for each sailor in the sailors table, for each sailor in the sailors table, I'm going to iterate through every sailor, like a for loop. And for each sailor, I'm going to check this condition, which is I take the sailor ID of the current sailor record and check whether this is true or not. If it's true, I will return the current sailor record and redirect to the select clause, meaning I will print out the current sailor's name. If it's false, I will do nothing. Okay? That's kind of the way you understand this query. Does that make sense? That means that this query now should become super clear to you guys, right? What it does is the inner query finds the sailor IDs who reserve 103, both ID 103. And then the outer block simply goes through all the sailors one by one and check if a particular sailor ID exists in that set or not. If it does, I output your name. If you don't, I ignore you. That's it. Any questions? Go ahead.
So the outer block is an actual set because you're only checking. You go through each one.
You go through each one. Yeah, it's like a for loop.
Yeah.
Okay. Very good. Okay. Now, before I go to the next example, now think about what's the difference between this query and this query. I'm going to ask one of you to answer this. Okay? Can someone tell me what's the difference between this query and the query we just saw before? Are there any difference? No difference? Go ahead.
So it changed the multi-set to a set.
It changed the multi-set to a set. Excellent. But did it with respect to the whole query as a whole, right? Did they change anything at all?
I think that only like when one SID shows up with a record, that's only going to appear, but it has multiple records, it won't show up.
So let me ask you a very simple question, which is what I asked him just now, which is, with respect to the final output, is there any difference or not? Yes or no? Like, it's kind of like you give me a long analysis of yesterday's game. I stop you and say, tell me who wins the game. Is there any difference in the final output or not? Yes or no? Okay? Think about this. So this is a list of seed IDs I'm going to show here. I use 103 for both IDs, so I'm going to use something else for the seed ID. Let's say seed ID start from 1 to 100. But suppose I have something like this in the inner block. Okay, what does this tell me? This means seed ID 1 reserve both 103 3 times, seed ID 2 reserve both ID 103 once, seed ID 5 reserve both ID 103 twice, and seed ID 4 reserve both 103 once. So far so good? Now my output block is, let's say 1, 2, 3, 4, 5, 6, meaning 6 sealers. What's the final output? A particular value. I take each one of this, I check against its name, right? That's the way to understand this. So this is fine, this is fine, this is not okay, it's okay, this is okay, this is not okay. So the final answer is 1, 2, 4, 5, and the names of those sailors, of course. That make sense? Like a for loop. Right? I hope you all know what for loop is. Okay? Now if I use distinct, how does this query change? This part stays the same, the outer block stays the same, the inner block will become this. So yes, the intermediate results is changed, the final output stays the same. Okay? Now, one more trick. Will this lead to the same output or not? Go ahead.
Yeah.
You think it will lead to the same output?
No.
Okay. Very good. We have a rivalry here. Can you explain why?
Because some IDs might share, different IDs might share the same name. So you might.
Excellent. If I change this, by the way, to your answer when you said yes, if I change this to this, your answer will have incorrect. Because seed ID is the key. Look at this. If they did both reserve both 1, 3, they should have no duplicate in the final output. But since I'm predicting out the name, not the seed ID, you may have, as he said, you may have duplicate over names though. Like both seed ID 1 and 2 may be named Dustin. Right? So there will be a potentially different output because of this. Of course, your output may still stay the same if your names are distinct to begin with. Okay? All right, to find the sailor who have not reserved 103, what do you do? Well, instead of using in, you use not in. All you need to do is to change this to not in, and you're done. The semantic of that is simply this. That's it. Or not. Okay, you flip the left and right, you got it now. More complex examples. Okay. Now, I'm gonna introduce one more keyword. Unique. So we saw this keyword before in the construction of create table statement, right? Unique can be used as a keyword to specify what? Your candidate key. Right? You can use unique to specify one column or combination of columns serves as one of your candidate keys. Does that make sense? Like the table, student, SID, you see this is the primary key, login, char 20, and let's say age, integer. At the end of it, you can see unique login. This means that in addition to SID being a primary key, login become a candidate key, right? So we saw this before. But I'm going to overload this operator. Overload this operator. Overload means that this operator under different contexts can do different things. So now in the construction, that's in create table. But in SQL query block, if I use unique, what does it do? It gives me a Boolean value expression of the following, which is to say, if somebody writes something like this, okay. First of all, this is again a Boolean expression, meaning that the evaluates only true or false, not anything else. And this evaluates to true and false. Evaluate to true if and only if A is a set. False otherwise, implying that A is a multi-set. Okay? So that's the semantic of this query. Question over there, go ahead.
So is unique, when we just select the string,
Say again.
it become pointless almost.
Can you speak louder? I have a hard time hearing you.
If we do select distinct, does unique become pointless?
Oh, you mean with respect to this particular example?
Yeah.
Okay, I haven't gone that far yet. I'm talking about the definition of unique. Any question with respect to the definition of it? Okay. So basically, unique, if you think about it, is to test whether a set, a multi-set is a set or a multi-set. Meaning that, in other words, whether the given instance has duplicates or not. If it does have duplicates, unique evaluate to false. Otherwise, if it has no duplicates, evaluate to true. So let's look at what this query does. I have the distinct to begin with. Let me remove that distinct. Okay, can someone tell me what this query does? By the way, in order to understand this query, I also tell you a special case is what is unique over empty set, right? Do you consider an empty set a set, duplicate free, meaning, or it has duplicate? In this case, we're going to use the convention that this is equal to false. Okay? Unique over empty set, we consider that it's not well defined, and we consider that false. So now, that being said, what does this query do? So the inner block, what does the inner block do? Can someone tell me what does the inner block do? What does the inner block do? That should be easy for you guys, right? I'm not talking about unique, I'm just talking about the inner block itself. Go ahead.
This would just show multiple 103s.
Potentially multiple 103, or 0 103 at no 103 at all. Empty set. Why? What you're doing is, as I said before, the way to understand nested query is to view this as a for loop, a nested for loop, right? For each sailor in the outer block, you iterate through those sailor records. And for each sailor, you execute the inner block using the current sailor record. So what the inner block does is take the current sailor ID and probe into the reserve table and check if the current sailor has reserved 103 or not. If it does, you return all those records by printing out the bold ID. And in this case, bold ID is guaranteed to be 103 because you have an equality condition on that. So how many 103 you get output? You get to the output depending on how many times the current sealer has reserved that bold 103. If the current sealer reserves 3 times 103, I will have 3 103 IDs. If the current sealer reserves 103 4 times, I will have 4 103 values. If the current sealer reserves none of 103 at any time, the inner block will simply be an empty block. So far so good? Yes? Question over there.
So does this whole block just say if 103 was reserved one time only or not?
You mean the entire block?
Yeah.
Yes, you are jumping ahead, but yes, the entire block is to say actually more than what you said, which is find me all the sealers who reserve 103 only once and exactly once.
With the unique keyword, if it's a multi-set on the inside, does the
It's
query
false,
just...
right? It's valid to false means that the current sealer will not be returned. If
So
you
it
reserve
won't
103
return
more than once, you will not be in the output. But if you reserve 103 exactly just once, you will be the output. In other words, this query finds all the sealers who reserve 103 exactly once. Because I said, I already told you, unique over empty set meaning false, meaning that those sealers who never reserve 103 will be eliminated anyway. And those who have reserved 103 more than once, unique will be evaluated to false. That's to say unique. You are evaluating unique over like something like this. This means the current sealer has reserved 103 times, and this is false. So the current sealer will not be returned. Only if it's like this will be true. Okay? Questions? Now, trick play. Right? Always you need some trick play in order to win the game, right? Like what happened before the halftime. Right? So trick play. Now what happened to this? What this query does? I add a single word. Is the query giving me the same thing or different? I'm going to ask this guy to answer. Yes, go ahead.
So when we add this thing, it's going to...
Can you speak louder so everyone can hear you? Yeah?
So when we add this thing, it's going to add everything's going to be unique, so all uniques always return true.
Not always return true. There are those who are empty set, right?
Yeah.
So what you said is almost right. When you add distinct, the inner block will be duplicate free. So what this query does is find me the sealer who reserved 103. That's it. I don't care how many times you have reserved it. After applying distinct, I will remove all the duplicates. So unique will always be true as long as you have reserved 103 at least once. But for those who have never reserved 103, this will still be false. Because distinct over empty set gives you empty set, unique over empty set still is false. Was it good? Okay, that's the trick play. Okay? All right. And there's another keyword called exists. Exists is like defined like this. And evaluate to true and false is a Boolean operation. Evaluate to true if A is not an empty set. Otherwise, it's false. Meaning that A is an empty set. So now that being said, let me change this query to this. Can someone tell me what this does? Can someone tell me what this query does? Go ahead.
Returns a list of any sailors that returns the names of any sailors reserved above.
Yeah, both 103 by the way.
One.
Not any both. We don't both 103. Because as long as the inner block is not empty, meaning that you have reserved 1 of 3. And there's no difference between this and there's no difference between the two. Okay? There's no difference between the two because you are simply checking whether something is empty or not. Removing duplicates does not change the fact that it's empty or not. It reduces the size of the set, but it doesn't change a non-empty set to an empty set, nor an empty set into a non-empty set. It doesn't change that property at all. Okay? So the last comment I'm going to have for you guys is comparing this query with this query here. What's another fundamental difference between the two nested queries we talked about today? This is what we call uncorrelated blocks. Uncorrelated or non-correlated. Okay, uncorrelated block and correlated block. The fundamental difference is the following. If you look at this inner block, the content of that inner block, the instance produced by that inner block, is a constant while you are looking through the records from the outer block. Meaning that no matter which serial record you are looking at from the outer block, the instance produced by that inner block is a constant. It doesn't change. In other words, the behavior of your inner block is independent, or in other words, uncorrelated with the behavior of your outer block. Is that clear? That's why it's called uncorrelated block. Now, this is a correlated block. Correlation in general means that the two things are related somehow, right? Correlation means that the two things are. For example, snow always happens when temperature is low. Snow and low temperature go together. That makes sense? That's a correlation. The two are correlated. You follow a simple example? Now, this is a correlated block because the content or the instance produced by the inner block will change. It's no longer a constant depending on the behavior of your outer block. Meaning that for different serials you are looking at from the outer block, the output of that inner block will change. It's no longer a constant. That's why it's a correlated block. Does that make sense? All of you follow this? By the way, in general, right, I want all of you to remember this. There's a difference between correlation and causality. Causality means A causes B. When A happens, B will happen. Correlation is A and B happen together. You follow this argument? Go back to the example I just tell you, right? Snow and low temperature are strongly correlated. What does it mean? When it snows with high probability, you're going to have low temperature. But this doesn't mean causality. For example, low temperature does not cause snow. It may contribute to snow, but it's not the single factor that will cause snow. You follow the argument? Oftentimes, but in real life, oftentimes people confuse correlation and causality. Whenever you see correlation, you say, okay, A causes B. No, that's not true. It simply means correlation. Correlation doesn't mean causality. Okay? So in this case, however, we have correlation and we have causality. The content of that inner block change is correlated to which record you're looking at from the outer block, they have a correlation, and the change is indeed caused by the fact that you're looking at different serial records. So you have both correlation and causality. That make sense? So more set operators. There are a few more set operators than we're done. Okay? I'm gonna define them on the whiteboard, then look at some examples. You can use set operator to do arithmetic comparison as well, instead of just logical comparison. So far, we're looking at logical operators, logical comparisons involving a set, right? Something exists, something is unique, some value exists in a set. Those are what we call logical operators. You can also do arithmetic operations, arithmetic comparisons involving a set. For example, you can use value, you can use a logical operator on P. This is a logical operator, such as greater than or equal to, right? And you see a value is an operator with any followed by a set. This A is a marked set. And this evaluates to either true or false if and only if for any, what that means is for all values in A, there exists a value in A such that value with operator X is true. And evaluate to false otherwise. Okay, what does it mean is, let's look at a specific example. Let's say I want to find all the seeders whose rating is above one of the seeders named as Horatio. Suppose we want to compete against this family, right? Compete against the Horatio family. And you say, okay, I will be happy if I beat one of the seeders from the Horatio family. I don't care who I beat. If I beat one of them, I can beat all of them, or beat two of them, or three of them. Doesn't matter. If I beat at least one of them, I feel good about myself. Does that make sense? So that's what this query does. Very good. But let's say you're really gonna compete against this Horatio family. You really want to compete against them. Beating one of them is not good enough, right? You want to beat all of them. How would you do that? Well, you use a keyword called greater than all of them. And this will mean that you have to be, this condition must be true for all values in A, rather than just for some value in A. Okay, that's the difference of two. The definition of all the set operators is given on this slide. So whatever I wrote on the whiteboard is available in this slide. Okay, now that being said, earlier we said intersection is not available in all commercial data engines, right? As it's not one of the basic operators for relational algebra. Henceforth, many commercial engines choose not to implement intersect. You may wonder, okay, how do I express intersect? I know how to do that in relational algebra. I use set difference. Is there any other easier way for me to express intersect in SQL? The answer is yes. You can use the keyword, for example, in. You can use the keyword in. So you can rewrite an intersect query using the keyword in, such as, for example, the outer block. If you look at this example, the outer block find all the SATA IDs who reserve red color vote. Right? And the inner block find all the SATA IDs reserve green color vote. I'm going to connect the two together by using the condition in. So for the outer block, in addition to enforce the join condition between reserve and vote, and enforcing the condition color is red, I'm also enforcing the condition that the Theta IDs must be one of the Theta IDs from the inner block. And the inner block tells you the Theta ID to reserve green color. So all in all, what this query does is to find Theta ID reserve both red and green color. That's like intersect the inner block with the outer block. Okay, so the effect is just as doing an intersection between the inner block and the outer block. Similarly, the set difference except operator can be rewritten using not in keyword, meaning that if I do this, then it's the same as doing a set difference between the outer block and the inner block. In other words, you're doing except between the inner block and the outer block. The same thing. Okay, now let's talk about division, right? We talk about division in relation algebra, right? Find the Theta reserve of both. How do you do this? Find the Thetas. Let's say find the Theta names who have reserved all the votes. We talked about this before, right? So I'm not going to repeat myself. I'm just going to write down the relational algebra query for this. If you don't understand the relational algebra query for this, you need to go back and review. So we talked about this more than once. The idea is you print out all the vote IDs from votes, and you need to print out the Theta ID and vote ID from reserve before you do the production, before you do the division, because otherwise you are finding all the Theta IDs who reserve all the votes on the same date. So you get rid of the date values. You don't care about that. So the final output of this is a list of Theta ID who reserve all the votes. Because I'm interested in the Theta name, I will join with Thetas, do a natural join between the two. Then I put out the Theta name. I'm done. Okay? So that's the query in relation algebra. Okay? Questions? Now, how do we do this in SQL? Unfortunately, there's no such operator called division in SQL. So you have to express division using the features of SQL we have talked about so far. Using the feature of SQL we have talked about so far. Okay? Here's how we do it. We use something called double negation. Okay. Double negation means compared to the following two statements. Okay? Think about the following two statements. I will play tennis tomorrow if it's sunny. Versus I will not be playing tennis tomorrow if it's not sunny. Are the two the same? Huh? Some say yes, some say no. Think about it. I will play tennis. Okay, forget about that example. Let's just come back to this. Okay? Yeah, I don't want to trick you too much. Right? You can think about that example yourself offline. Come back to the boat example. Okay? I want to find the Theta reserve all the votes. I want to find the Theta who reserve all the votes. So what I'm going to do is to use this so-called double negation logic, which is to say, okay, first of all, let's look at the structure of this query. It's a nested query with two levels of nesting. Think about this as a for loop, nested for loop. For I equal to 1 to n, for j equal to 1 to m, and for l equal to 1 to x. So I have three levels of nesting. That's a way to think about it. And what I'm doing is, for each Theta, that's the outermost block, I iterate through all the Thetas. For each Theta, I'm going to return this Theta if I use not exist. Not exist means that if that block is empty, I'm going to return this Theta. Otherwise, I will not return the current Theta, right? So I'm going to repeat this for here. So for each Theta, as, what I'm going to do, I'm going to return as if that inner block equal to empty, right? That's what not exist means. So far so good? All of you follow this? Right? I'm doing a breakdown of what's going on over there. Now, what is this inner block? If you think about logically, which the sailor who reserved all the boats is equivalent to the following, which is I cannot find no boat that he or she has not reserved yet. No boat as has not reserved. Right? That must be a sailor who has reserved all boats. You follow this logic? Yes? But no boats as has not reserved is the same to say boats as has not reserved equal to an empty set. That means the sailor who have reserved all the boats. You follow this idea? So what I'm doing in my inner block, but this, if this equal to empty set simply means this is not exist of this. The boats as has not reserved. Now you understand, that means that you understand from here to here, the mission is to find the boats the S has not reserved. Okay? So how do I find the boats S has not reserved? Let's do this one by one. How do I find the boats S has not reserved? So my objective becomes this. My objective reduces to this. Boats that a particular sailor has not reserved. A particular boat, to show that a boat B S has not reserved, how do I do that? To show that a particular boat S has not reserved, what do I do? Well, there's no reservation record on S over B. Period. If that's the case, this boat S has not reserved this boat. If there's no reservation record showing S reserving B, then that must be a boat S has not reserved. All of you follow this logic? Was it good? How do I show there's no reservation record on S over B? Well, that's to say, to do this, I will say not exist select a reservation record where SID equal to S and boat ID equal to B. That's it. If this is not exist, meaning that this is empty, that means this S has not reserved this boat. Right? Does that make sense? So you select such boats. Where this. And this gives you boats as has not reserved, so this is replaced. That's your two-level nesting. You're done. Now transfer to this query over there. Okay? So let me work through this query one more time. For each sailor, you're trying to find those boats he or she has not reserved. In order to do that, I go over the boat and see whether there is a reservation record on that boat ID and sailor ID. If there's no such reservation record, that means this boat must be a boat he or she has not reserved. If anything is returned here, that means you have not reserved all the boats. Otherwise, you must have reserved all the boats. Okay, so that's how we apply this double negation logic on this specific construction of division. And that's how you do division in SQL, using this double negation logic. Questions? Go ahead.
Show maybe an example like with 3 votes or something.
Say again?
Can you show maybe an example of this? Like how would
Show me
like if there, let's say there's like 3 votes,
Uh-huh.
like 3 different vote IDs.
Okay, let's say seed ID 1 reserve both ID 1, 2, but not both ID 3. So that the sealer doesn't reserve all the votes. So when you come to this inner block, you will find both ID 3 because there are no records showing seed ID 1 reserve both ID 3. Meaning that you have not reserved all the votes. On the other hand, if there's another seed ID 2 who have reserved all the vote ID 1, 2, 3, with respect to that sealer, you will find no vote ID. There are no reservation records showing that sealer reserving a vote. Meaning that that must be a sealer who reserved all the votes. That's a particular example I can give you. Okay? Question on this? Okay? Now let's move on. Do I have time? Okay, so far, you notice this slide, right? We talk about the basics of SQL. The trick play has not taken yet, so these are some basic playbook stuff, okay? So next, on Wednesday, we come back and talk about more complex construction, okay? See you on Wednesday.
That works.